Now we built the foundation with combinators and added cross-cutting concerns with wrappers. Now let's make this user-friendly with a third pattern, domain abstraction. This pattern creates high-level interfaces that speak naturally about your problem domain. Combinators and wrappers give you building blocks, but they're still relatively low level. Now consider the difference between the two approaches shown here. Both accomplish the same thing, but look at the difference in readability. The low level approach reads like instructions for how to accomplish something. Create a read step, then chain a filter step, then chain a transform step. The domain abstraction version reads like a description of what you're trying to accomplish. Read from users.csv, filter by email, transform by adding country, and write to output.json. Now, here's how you build effective domain abstractions. Let me walk you through this implementation. The pipeline class internally maintains a list of processing step objects, but it hides this complexity from users. The create method is a static factory method that returns a new empty pipeline. This is a common pattern that makes the API feel more natural. Each of the Fluent methods like read from, filter by, and transform does two things. First, it adds the appropriate low level step to the internal list. Second, it returns the current object, which enables the Fluent chaining. When you call the pipeline's create method followed by read from, the read from method adds a read step to the list and returns the same pipeline object. So you can immediately call another method on it. Now look at the with logging method. This is particularly interesting. Instead of adding a new step, it wraps the most recent step with a logging wrapper. This allows users to selectively add logging to specific steps without changing the overall structure. The execute method is where the magic happens. It takes all the individual steps we've collected and combines them into a single pipeline using the combinator pattern we learned earlier. The reduce operation starts with the identity step, which just passes data through unchanged and chains all the steps together using and then. Notice how each method returns the current object, this, enabling the fluent chaining that makes the DSL read naturally. But the real power comes from being able to express complex scenarios naturally. Now, let me show you a couple of examples. Look at the example on the left. Look how naturally this reads. We read sales data, add logging to the ingestion step, filter for records with amounts, filter out negative amounts, add logging to the validation, add a process date, determine the tier based on the amount, add logging to the enrichment, and write to JSON. Each step builds on the previous one, and the logging is sprinkled in exactly where we want. The right one, there's a completely different use case using the same vocabulary. We are processing customer feedback instead of sales data, filtering for records that have ratings, transforming the numeric ratings into a sentiment category, and writing to a different output file. The key insight is that domain abstractions make your code self documenting and accessible to domain experts who might not be programmers. A business analyst could look at these pipelines and understand exactly what they do without needing to know about combinators, wrappers, or any other implementation details.